Today we are learning how to divide polynomials by a monomial. It's like distribution, but the opposite. Instead of distributing the outside term, we're going to divide every term on the inside by the outside. Dividing every piece by 10v to the third is not that bad. We look at the first, 50 divided by 10, and we can reduce that to either 5 or 5 over 1. Now we need to look, where are there more v's? There are more v's on the top. How many more? 2. Our second part is 4 over 10, which we can reduce to 2 over 5 by dividing by 2. Where are there more v's? And how many more? More in the bottom, and there's one more. So you can put an invisible 1 or just leave it as 5v. We know 50 over 10 is 5 over 1 from our first portion. Now our v3 and our v3 would leave us with v0, or where are there more? Not the top, not the bottom, they're equal, so they cancel out. Now this problem on your ECA may be written like this instead. Either answer is acceptable. Let's move on to a different one. We are also going to learn about factoring out the greatest common factor. In this case, we don't have parentheses, but we're going to create parentheses by factoring out the biggest number and the biggest letter that goes into everything. We have 16n to the fourth and 16n and 4. Let's look at our smallest number, 4. Since 4 goes into 16 and 16, we're going to go ahead and factor out a 4. So we have 4 is part of our GCF. If we go ahead and divide everything by 4, that's great. We don't need to divide by an n because there's not an n in the last expression. There's only an n in the first two. So all we can divide by is the 4. Since we're factoring it out, we need to leave the 4 out, outside of parentheses. Factoring out indicates parentheses. What's 16n to the fourth divided by 4? 16 over 4 is just 4 over 1. Which we can write as 4, and n to the fourth would stay on the first level of our fraction. 16 divided by 4 is 4, and n would stay on top. And 4 over 4 is 1 over 1, or just 1. Our answer is complete. We've factored out the greatest common factor. Let's go to one that has a variable in it. Let's look at number 7. It's a little bit different because it has two variables, an x and a y, but we're still trying to find our greatest common factor. So look at your smallest number, 4. Does 4 go into 20 and to 8? Yes, it does. So 4 is part of our greatest common factor. Now look. What is the highest power of x that goes into each of the expressions? This would be a single x. It's the largest power of x that goes into all three. So we can also divide each expression by x. So we'll put an x by the 4. Now look at the y's. At least one y goes into each. So we need to divide by a y. The highest power of y that goes into all three. Let's go ahead and write our GCF on the outside, our 4xy, and draw some parentheses. 4x to the third y divided by 4xy. Well, 4 divided by 4 is 1, so it goes on the top, or 1 over 1. Where are there more x's? On the top. So we can just write x2. We don't need the basement anymore of our fraction house. Our y's can cancel, so we don't need to worry about those. 20 divided by 4 is 5 over 1, or just 5. Where are there more x's? Well, they're equal, so you can cancel them. Where are there more y's? 2 more on the top, so y to the second. 8 divided by 4 is just like 2 over 1. Now, since all the variables are higher in the top, we don't need a basement of our fraction house. There's 1 more x on the top and 3 more y's on the top. And this will be our answer after we've factored out the GCF. Our last expression today that we're going to find the greatest common factor of is number 15 on your worksheet. Now, 35, 35, 42. 35 does not go into 42, so we need to look for other factors of 35 that will go into 42. The greatest common factor they share is 7. So 7 is going to be factored out. So we can draw a little 7 underneath all of them. Also, we need to look at the y's, the z's, and the x's. They're all in each expression, but what is the biggest power of y in each one? We have a y to the 4th, a y to the 4th, and a y to the 3rd. So the one that goes into all of them is the y to the 3rd right here. So we can divide each expression by y to the 3rd. All right, now looking at this, what's the biggest power that goes into all of them of z? We have z to the 5th, z to the 4th, and z to the 4th. So we have to go with the z to the 4th. It goes into all of them. Looking at these three, x goes into the last 2 parts, but not the first. So if it does not go into all 3 parts, we cannot divide by it. Instead, we have found our GCF, and we go ahead and write it down outside of parentheses. We draw our parentheses, and we divide each term by the GCF. 35 divided by 7 is 5. Okay, and it's 5 over 1. You don't need to draw the basement though, you'll see why. Where are there more y's? On the top. How many more? 1 y, so we leave 1 y up there. Where are there more z's? On top, we leave a z up there. So you don't really need that one in the bottom. Same goes with the rest of the expression. 42 divided by 7 is 6, positive 6. Where are there more y's? The top, how many more? 1. The z's actually cancel because they're equal. And then the lonely x stays on the top. 35 divided by 7 is 5. The y's can cancel because there's the same quantity above and below. Same with the z's. How cool is that? And we keep our x with the 5. We've now factored this expression, and we don't really need this one in the bottom. So if you want to erase that, you can. And have our 5yz. You've now learned how to divide polynomials as well as factor out the GCF of polynomials. I hope this helps you as you prepare for your quiz. Good luck, and I'll see you tomorrow.